Okay. Um, Hello everyone. This is just an architecture video, and I'm going to be teaching you one of before we continue with performance issues and IAS. I want to take a step backwards and then teach you a rather important topic that you're going to find in a lot of situations, which is program execution. Okay, not a lot of situations, but I mean it's free 20 marks in the exam, and it's a very fun concept to learn. Yeah, because it's actually not very hard. So you guys have talked about IAS and you've actually even used the IAS simulator. But for us, like in Mindtech, we were just doing this stuff by hand. So we didn't have the IAS simulator to simulate how the accumulators were working. So it was important to understand what each of these registers do, right? So over here what I have is memory. In my memory I'm just going to put something very simple. I'm going to say this let me put 0005 0002, and then here we're just going to leave it blank. Then here I'm going to put 1 520 2 521 3 523. So I just have a simple so here we have our memory, right? So you guys have talked about IAS, right? So over here we're just creating our own IAS machine, right? So this is our memory, and then this is our CPU, and then in our machine, the machine that we've made as our theoretical machine, our theoretical machine only has an accumulator, a program counter, and instruction register, right? So I'm just going to go over what each of these does, and then we're actually going to execute this program that we have here in memory by hand, right? We're going to execute this program by hand. Then later on we can even just write it in the IAS just to make sure that okay, what we're doing is actually right? Okay, so first of all, what the registers do. So over here, first of all, I have a simple instruction set. So instructions, right? So over here, if my instruction is 1, it means load from SC to accumulator. So we're going to load from memory. So we're going to get from a memory location to accumulator. 2 is add from memory and put it into the accumulator. Then 3 is store from accumulator to a memory location. So just my basic instruction sets that we have for this IAS that I've just come up with. And in most cases in the questions, you won't be working with a standard IAS model. You'll be working with like generic computers. They'll have different registers. So understanding what all registers do is important. So when your CPU is executing your program, there are 2 cycles, right? So execution cycles, right? What are these? The execution cycles, this is well, what happens when your CPU is executing, and you have 2. You have the fetch, then you have the execute, right? So what fetch does, fetch is basically get something from memory and then bring it to the CPU, right? Then what execute is basically do something with the CPU from with what we fetched from memory. And then of course this can have a lot of different things. It can be, one, we can either be getting something else from memory, like loading something from memory, or we can be taking something to memory, or just within the accumulator, within the CPU itself, right? An example is usually during the fetch cycle is when we get our instruction, right? During the fetch cycle is when we get our instruction. Then during the execute cycle, right? During the execution cycle, that's when we during the execution cycle is when we do something with that instruction that we fetched from memory. So say we fetch this instruction, right? We put it into our instruction register. So in fact, let me just explain what happens to registers now. So in this case, so you've talked about the MAR, MBR, program counter, etc., instruction buffer register. But for in this case, we're going to look at the AC. So we're going to look at AC. Right? What is the accumulator? So the accumulator, we know that it stores a value. Stores a value, right? This basically stores a value from memory. And we also use this to run mathematical calculations and do other stuff. So that's the purpose of the accumulator. Then we have the program counter. What the program counter does is keeps track of where we are in the program. So keeps track of next instruction to be fetched. What does this mean? Well, basically it means that if during our fetch cycle, right, during our fetch cycle we say that okay, our PC is at let's say memory address 300, it means that during that fetch cycle what we're going to do is that we're going to fetch whatever is at memory address 300, right? So I say if in instance here we are the 300, if we're at the 300, basically what we're saying is that get whatever is at memory address 300, right, put it in the instruction register, right? Then if we say then in the execute cycle this increases by 1. That's just one thing to know. So the program counter just keeps track of where we're going to fetch our next instruction from. Then our instruction register, in this case, it stores the next instruction, right? So it stores the next instruction that we're about to execute, right? And from what you guys have learned, if I'm not mistaken, you've talked about the basic structure of the IAS command, right? And what that IAS command looks like is that, so in the IAS we're able to store a single memory location. Can do things. It can store data or it can store an instruction, right? So in this case what we're going to do is that well, if you've noticed my memory locations here, so these are in a number format called hexadecimal, hex, right? They're in a number format called hexadecimal, right? They're in a number format called hexadecimal. Just give me a moment.